Now we know all 8 types of correlational structures. However, we should really only pay attention to the causal types, since that's what we're after. I only wanted to show you all the scenarios to give you broader perspective, so that you can be wary of all the scenarios where the relationship is not causal. There is a checklist to figure out if there is enough evidence to say that a causal relationship exists between a set of variables. And broadly speaking, there are 5 boxes that need to be checked, and they are time order, covariation, significance, rationale, and non-spuriousness. We'll talk about them one by one. The first thing we have to note is the time order, where the cause must have occurred before the effect. And this makes sense because for X to cause Y, it must be the case that X occurs before Y. As an example, if we want a study of smoking causes cancer, we are necessarily supposing that smoking precedes cancer. Otherwise, we have to reframe our question, and say that we want a study if cancer causes smoking, which admittedly sounds silly. The second requirement is covariation, which is another way of saying that there must be correlation between 2 variables of interest. Otherwise, there wouldn't be a causal relationship, for no correlation means that there is no measurable association between 2 variables. And for X to have caused Y, there is necessarily an association. The third requirement is significance. What significance means is that in any study that involves studying a sample of a population, there is always the possibility that the sample is not representative of the population. For example, suppose we take a random sample of the heights of people in the US to get a feel for the average height of US residents. But in our sample of 10 people, we get really unlucky, and get 3 basketball players, greatly skewing the average height upwards. Similarly, in our study, we may collect data from a sample of the population, and observe a causal relationship between 2 variables that could have just occurred by chance. We can cover the statistics later when we get to it, but for now, just know that we are going to check for the statistical significance of the causal effect that we observe in our sample, so that we can confidently say that the causal effect is real, and not due to chance. The fourth requirement is that there is rationale, meaning a logical compelling explanation for a causal relationship. Just because is not a good rationale for explaining why there is a causal relationship. This is a pretty underrated requirement to establish causality, and maybe so, because it comes as obvious to most of us that there must be an understandable rationale behind a causal relationship. The last thing on the checklist is to check for spuriousness, which means that we have to be sure that it's the variation in X that causes the variation in Y, and nothing else. There can't be a variation in W, or some other variable that is actually causing the variation in Y. Simply put, rival explanations must be ruled out.